Okay guys, looks like my video got cut off in the previous video, but I just wanted to explain you that none of the OA, OB, OC, OD, those are the slant edges which are seen in top view. None of them is parallel to VP. So now I'm just making it parallel to VP or XY line. Then project this line over here and then get the projection line. This is your, okay, if I say this is my C2, this is my C2 dash, this is my true length. Okay, this will be coming handy for us in the coming up topics, that is basically your developments of surfaces. Okay, just remember this is the straight lines concept. Okay, coming up in the next problem, we'll just move on to the next one. So this is a tetrahedron. If you understand what a tetrahedron is, tetrahedron has all equilateral triangles, that is like OA, OB, OC, OAC and ABC. All of these OAB, OBC, OAC, ABC, all of them are equilateral triangles. Okay, this is your tetrahedron. Okay, it is a kind of a pyramid. Okay, not quite a pyramid, but it's a kind of a pyramid. Alright, so here all the faces are triangular faces. In a pyramid, we have the base shape as a regular polygon. The rest of them are all isosceles triangles. All the faces are isosceles triangles in a pyramid, except for the base shape. Base would be a regular shape, regular polygon. Okay, whether it's a triangle or a square or a pentagon, hexagon, whatever. Alright. But however, if it's in tetrahedron, the base shape is a triangle, that's an equilateral triangle or regular polygon. And all the faces are also triangles or equilateral triangles. All the faces are equilateral triangles. Okay, the base is also an equilateral triangle. There is like 4 equilateral triangles put together to get a tetrahedron. This is what a tetrahedron. This is central point. This is the axis point. So from the center of the triangle, this is the height. Okay, this height is not known. It will not be talked about in the question also. As we see in the question here, tetrahedron of the side 50 mm is resting with its face on VP. Okay, so out of all the 4 faces, okay, the face could be called as a face or a base in this case. Okay, if it is resting on a certain reference plane, it will be called as a base. Otherwise, it can be called as a face. Okay, 4 faces. Its face on VP and one of its base edges is perpendicular to HP. Okay, this is the opposite now, just a little opposite of what we have done earlier. Base edge is perpendicular to HP, its axis is 35 mm above the HP. An auxiliary vertical plane whose trace is making an angle 35 degree to XY is passing through a point. Okay, let us get to the base shape. Okay, where is the base shape now? Since it is with its face on VP, so the face is one of the faces resting on VP, so I'll just start off with the base shape. Okay, I'm just taking the one of the base edges perpendicular to HP. That's the reason why I'm taking it like this. This is an equilateral triangle, so I'll just take whatever side this is, then get my equilateral triangle. This is my equilateral triangle. So this is my central point. Okay, I'll just draw the slant edges here. Since it's a pyramid, this slant edge has supposed to be, this is O dash, also this is A dash, B dash and C dash. So this is basically parallel to XY line. So now he's saying its axis is 35 mm above the HP. The axis would be this is the central point. So from here till here 35 mm, I'll just draw one line here. This is the projection line of the axis. Now this is my XY line. Alright. This is my XY line. And then I have my one base edge is perpendicular VP. This is my axis point. From here till here, this is 35. As per the question, I'm just going through and then getting the base shape and all those things. Now, let me get the height of the axis. I don't know the height of the axis in this case. So it's a tetrahedron, like I told you. The height is not given. But only point what we know is this OB is parallel to the XY line. Okay, OB is parallel to the XY line. And this side is given as how much? side is 50, right? So this is 50 mm. One side, this is 50, 50, 50. These are also 50, but apparently in the front view I don't see it as 50. This is little less than 50. Right, but now that I know O dash B dash is parallel to the XY line, from here till here, what I do is I'll just draw the axis line. Okay, I'll just take whatever the axis line is. I don't know the height, but from B, this is my B, right? This is my B and this is my C comma A. From the top view, this is the top view, right? CA is seen, right? The base for the ABC base, that is also a solid line, right? That is seen as a solid line definitely. Now I don't know the height of this. This height is not known. Nobody has given me what the height is. So how do I find out the height? I know that O dash B dash is parallel to the XY line. So the top view of O dash B dash would be a true length. This is the true length, that is basically 50. Okay, you understand, right? I told you earlier also the straight lines concept. This O dash B dash is parallel to the XY line. Okay, so that means it is the true shape is seen in true length is seen in the top view. So this, or whatever this is, since it is parallel to XY line, here I'll see the true length. The true length is how much? 50 mm. So all the edges are 50 mm in this diagram. So from here, take your compass, mark 50 and then mark a point like this point, mark it here. So you'll get a 50 here. This is my 50. So this is my true length. Okay, this is 50. Remember this. But this is not 50 though. This is like OA or OC is definitely not 50. You can see the length variation. You can see this is my point O. This is my C and this is my A and this is my B. All the three edges are covered and my axis is covered. So this is OA, OC covered here. So this is the top view of this diagram. Okay, and then OB is seen. So now let us get to the point here. Now this is a section, an auxiliary vertical plane. Vertical plane is like this. Okay, whose trace means this is the plane. So the trace would be the plane's trace. If it's a line, the line is falling here. The line is making an angle, trace is making an angle 35 to the XY line and is passing through a point 15 mm from the apex. So from here I'll mark a point 15 mm. From here till here 15 mm. From there you take a 35 degree angle. 30, this is 35. Okay, this is 35. Somewhere like this. Okay. Now this is cutting the solid like this. This at the ends I'm making it thicken so that this will tell me that it's a section plane. Alright, now how many points is this line cutting the solid in? How many points, how many edges is the line or the section plane cutting the line? Okay, this is if I have to say, this is how much? Or you can put here 35 degrees. Right, now this is cutting, there is only how many edges? OA, OC, 2 edges, OB, 3 edges, only 3 edges, and then it's cutting the lateral surface. So obviously it is 3 points. So here I'll name, starting off whatever I see from the top, I see OC, I see OB. Right. So now OC is a solid line. So number 1, OB is a solid line number 2, and the CA is hidden. That is 3. Okay, 3 points. These are the 3 points where it's cutting now. Now, how do I get the sectional? He's asking sectional front view and true shape. Okay, so let us get the sectional front view. So to get the sectional front view, all I'm doing is just from here, just since my 1 and 3 are lying on these lines, I'll straight away project them onto here. And then this 2 is lying on B line, so I'll straight away project onto the O dash B dash line. So this is my point 2. So this is my point 1 and this is my point 3. So I'll just join these points to get my sectional front view. This is the section, the part removed. So wherever I'm removing the part, this part is removed. This is my observer is sitting here and seeing. So this part is removed. So whatever I see front, this is my front view, and then this is I see the section. So this is called the sectional front view. Right. This is the sectional front view, this is the section. Okay, when it is cut at an angle, this is the section. Okay, now I want to know how the true shape would look like. So how do I get the true shape? All I have to do is draw a line parallel to the section plane. To the section plane, I'm just drawing an XY line. So this is an auxiliary line. I can say x1, y1. Okay, x1 at a convenient distance. It doesn't matter. And then I'm drawing line perpendicular to this. Since it is an orthographic positions, this is my 1, 3 line. This is my 2 line. So both of them are. These lines have to be perpendicular to the next one. This is important. This is orthographic projection concept. So now let us know where is my point from xy to 1, whatever the distance is. So I'm just marking it here, and then xy to 3. Okay, this is 1, 3, and then this is my 2. So this is xy to 2. This distance is marked from here till here. This is 3, this is 1. Okay, you have to take the scale distance. Okay, exactly the same distance over here. Okay, so you need to have plan the space properly. So now this is basically, I have all the 3 points. So now I'll get the true shape. Okay, so this is just the opposite of what we have done earlier. This is your hatching. I'm just drawing a hatching setting 45 degree to the x1 y1 line. This is my x1 y1 line. So this is a 45 degrees. So this is the true shape. 1, 2, 3. This is the true shape. Alright guys, I hope you understood this problem. Please go through this. One is not seen here. So this is my 1, 2, 3. This is the true shape. So x1, y1 is an auxiliary plane drawn parallel to the section plane. This is the section plane. Parallel to this, I just drew it conveniently at a convenient distance without overlapping any of those shapes. Right. And then get the true shape. How do I get the true shape? From xy to 1, I measure that distance and then mark it from x1, y1 to 1. It's the same distance. This distance and this distance is the same distance. Similarly, xy to 2. And then x1, y1 to 2, xy to 3, x1, y1 to 3. So these distances are to be maintained correctly. Okay, this is your 10th problem. So this is a little different than what we have done earlier. So this is an auxiliary vertical plane. The earlier planes are auxiliary inclined plane. They can be called as AIP. This is like AVP, auxiliary vertical plane. That means this is perpendicular to HP. This is perpendicular to HP. You see the trace in this line in the top view. Okay, in the previous two cases, the plane are perpendicular to VP. So you see the trace or the section plane in the front view. All right, let's move on to the next question. So it's right here. Just note, I'll just read the question for you. Please note down. A hexagonal pyramid of side of base 25 mm and axis 60 mm long is resting with its base on HP such that one of its base edges is parallel to VP and 15 mm in front of VP. A vertical section plane making 20 degree to VP is cutting the pyramid 15 mm away from the axis and towards the observer. Draw the sectional front view, true shape and top view. This is similar to what we have done earlier, but it's quite different. Okay, the base is not in the VP but base is in the HP. This is the only difference. Okay, axis 60, 25 base, resting with its base on HP. Remember this. Okay, and then one of the base edges is parallel to VP and 15 mm in front of VPs. So let me get the base shape first step. The base shape is how much? One edge is it's parallel to VP and 15 mm in front. Okay, 15 mm from here I'll measure it. Then I'll get my 15 mm. Okay, since it's a hexagonal pyramid, I'll have to get my hexagonal shape here. Okay, you guys can use a protractor if you have to get the angles. or else you can use one of the methods which I taught you in the class. Now you get your hexagon. Okay, now this is your center point, so from the center point you will have to join the lines like this. These are your slant edges, remember this. Okay, your slant edges, get your slant edges, and I'm naming this as A, and then I'm starting off from here, counting A, B, C, D, E and F. This distance is 15 mm as given in the question, and whatever this side is given, how much? 25, right? So this is 25, I can take 25. And now what's the axis height? 60 mm. So from here, from the axis, I'll just draw the projection line and then take the axis height as 60 mm. Now, as I said, like now let me get the projection lines. This is my outline, first extreme line. Okay, first extreme line. This one, all I can do is directly I can draw the outline like this. I don't have to worry about O dash. This is my A dash. Okay, this is my D dash. So O dash, A dash, O dash, D dash is seen. Like my eye is right here. So OA, OB, OC, OD is also seen in fact. Okay, so let me project these two. So B is coinciding with F projection, and then C is coinciding with E's projection. So now I have to join OB and OC is seen, right? So I can directly join these also as a solid line. Okay, but use a H pencil though. Don't do an HB right away. We'll do it. We'll save it for later. So this is my B dash. This is my C dash, and this is my D dash. My E dash is behind my sight, and F dash is behind my sight. So O dash, F dash, and O dash, E dash are behind my sight. So I'm just putting them in braces, and then apparently they are dotted lines. But it's like O dash B dash is covering the O dash F dash line, and O dash C dash is covering the O dash E dash line. So this is what's happening here. However, you should know that O dash E dash and O dash F dash are dotted lines. Now, there's a slight change in what we are doing here right now. Now this is a vertical section plane. It's not a horizontal, it's a vertical section plane. It's making 20 degree to VP. This is 20 degree VP and cutting the pyramid 15 mm away from the axis. This is my axis, right? So 15 mm away. Okay, this is 20 degrees first thing, and then 15 mm away from the axis, then towards the observer is here. Okay, observer is here. This is my observer. Okay, so set your drafter to 20 degrees first step. 20 degrees. Now from here, 15 mm away. So this is my 15. I'm just moving 15 mm away from here. Alright, so this is my 20 degrees. 15 mm away, I'm just putting my 20 degrees, and now I'm cutting the cut here. You guys need to really understand these problems. So where is it cutting, and then where am I putting my base shape? These things you need to really understand. Okay, so by observation you will understand. Okay, now let us see in how many points, how many edges this thing is cutting. Okay, there's one line here. Okay, so now this is the region where it is cut, right? So now AB is cut. AB is cut definitely. OB is cut. We can see this definitely. OC is cut. OD is cut. And also ED is cut. ED is from the base. Remember this. Okay, so let me just count off from the solid line, starting out from left side or right side. It's up to you. You guys can decide on that. But I'm starting off from here. This is my first point, which is on AB. That's on the base. Okay. Now this is my second point. This is on OB. Okay, this is the slant edge. Okay, this is the third point, which is on OC. Right. And then this is my fourth point, which is on OD. And this is my fifth point, which is on ED. Okay, these are my